Hello everyone and welcome back. So now we're going to take a look at rendering the sparks, and I have the geometry or the particles read in. I'm going to go over a few things that I've done to prepare this. It's pretty self-explanatory, so I'm not going to recreate it from scratch. And what I'm doing here is I'm setting random colors. So this is the original sim. And then I'm generating a random attribute. 10% will be red, 30% will be green, and the remaining 60% will be blue. And then I delete the red just to reduce the amount of particles, or I keep the red and delete everything else. And then with a point VOP, let me dive inside. I do a few things. The first one is I want to scale the particle to 0 as a I want the particle to start 0 scale at 0 scale and then dies off at 0 as well. So I want to create a ramp that starts black and quickly goes to full on white and then stays on for the particle lifetime and then goes to 0 towards the end. And this is going to be a multiplier to the B scale, so we don't have any pop in or anything like that. So the way to do that is by dividing the age over life, and that gives us a normalized value that I plug in through a ramp. So this is ramp, and this is what the P scale multiplier looks like. So it starts black, goes to white, it lives on at that size, and then it dies off quick again towards the end. So that's going to be a multiplier, and then I also use another multiplier, which is the velocity. So the faster the particle moves, the bigger, and as it gets towards dying, or if its velocity becomes 0, then I scale the size all the way to 0 and it's no longer visible. So that's how we would kill it. And I'm using a fit range, so any particle that is not moving is moving lower than this will get 0 value, and then it will die off quickly. And I'm adding a little bit of randomization to vary this entire range per particle so that it's not uniform. I don't think it matters that much. But what I also thought about just now is we can use the ramp, the life ramp, to as a multiplier for the velocity. So the sooner, right before it dies, the particle gets a kick in the velocity value. This will only affect the render time, so the streak of the particle will become longer. And let me show you how we could do this. So I'm going to call this ramp val, and let's go up. So right now it's black, and I'm gonna let me think. Yeah, so basically I want this to be, I want the velocity value to be the same its entire lifetime except when it's about to die, so maybe here. And because it's black to white, I'm gonna dive inside and add a constant. So add constant, shift everything by 1. So instead of this being 0, it's now 1, and instead of this being 1, it's now 2. And I can use this as a multiplier to the existing velocity. And then bind export it as velocity. So this way we make the streaks longer. So that would be V, and it's a vector. So this is just an idea that you guys can explore. Let's go back up. So that's it for the preparation. That's it. I want to change the P scale based on their lifetime and their velocity. And if I go up, I have this node that imports the sparks. It's just I prefer to do this preparation in a separate node and then the render node separate. So what we need for this is we need to tick on velocity blur, because we're going to blur the particles based on their velocity. And under the geometry, I'm going to render them as circle. And because we have that orient attribute where the particles torque, the when we use circle, they're gonna spin. If we use sphere, it's gonna look the same from any angle. And the p-scale is set to 6 at the moment. So let me pick camera. Let me create a new camera. I want to get close to these particles. And it's a cam 4, so let's go here. And I already have a render node, so it's reading in, it's selecting the sparks, and I don't need any lights because these are emissive. And let's create, let's paste in the camera, and I'm going to create a shader. I'm going to call it sparks temp or sparks live. And inside, I'm going to create a standard surface. And I'm going to give them a orange tint. And I also want them to emit light. So under emission, I'm going to set this to 1. And change the emission color. Sparks live. And let's go to the render settings and hit render. And we have to make sure that we have a motion blur turned on. So in the render settings, motion blur is turned on, and the sampling for this to work properly, we have to have at least 8 to see the streaks properly. And I think it's not rendering from the correct camera. Yeah, it's not rendering from the correct camera. So let's hit render again. And what I'm looking for, yeah, it's to get these streaks, and we're getting them. And the trick is for the in the p-scale and the orient attribute, which is present in the sim, and then we have to render them as circles. So the only next thing that I want to add is some randomization in the colors. So let's do that. I'm gonna go to the shader, and I'm going to create a flat or a flat color. I'm going to set it to orange. I'm going to user import that. We have an ID attribute I'm going to access here. So let's make sure this is working. Plug it into a random. And I'm going to randomize the color. Okay. So it looks like it's coming as one attribute, and I will check it to see. So if we dive here, we have an ID, it's there. Let's see, let's try float. Sorry, the input type is integer. Yeah. Not color, and the result is color. Okay, so it's working. So let's do a color jitter node, and from input, so this is the data that we want to jitter, and this is the color. So the input, and then let's plug this in here. And what I want to do is I want to change from data, I want to change the hue of that color, and we can play with the saturation. The hue, we have to be careful. And now we're getting some randomization. I don't think we have to have a surface for all of this, but we'll use one, yeah, to get the alpha channel. And then for the emission, we're gonna multiply the color quite a bit. So because it's coming in, we're gonna keep the incoming color, and let's plug it into the emission as well. Emission color. And I want to randomize the emission as well, not just the color. So I'm gonna use a color correct node and take this and desaturate it completely, and it's gonna give me a black and white map. And I'm gonna use it to drive the emission. And then we can use this gain here to increase the brightness of the particles if we wanted to. So let's set this to 1, 2, and we can, I prefer to increase it quite a bit so that I have more illumination coming out of it, and then in the render or in comp I tweak it back. Okay, so that's our first camera. Let's go back and create another one and move it. I want to see how it looks from this angle, for example, and let's go to a different frame and let's change the camera to 5 and hit render. And the last thing we want from this is the illumination of onto the geometry. So we want these points to illuminate the geometry, and we can have all of this as in a single pass. The only downside is the settings that we need to render these particles are quite high, and that will impact the cost of rendering the indirect illumination. But we could do it in 2 separate passes and tweak the settings accordingly. Okay, so that's our pass. I'm gonna go back to camera 4, and I'm gonna use the so here I'm gonna change this to, I'm gonna leave it, I'm gonna render all in the same pass, and we need the RBD outer, the RBD core. And we have to make sure that we have indirect diffuse, otherwise it's not going to emit light. So I changed this to 1, and now we should see illumination off of this onto the geometry. And I don't see it. I think it's there. Yeah, it is there. This part, this element for the illumination, I don't think it's very important for the final visual because we're gonna have fire emit, but you know, we can have this just in case we wanted to use it, you know, to add extra interactivity to the geometry. Yeah, it is working. Okay, that's pretty much it for the sparks. Thank you guys for watching, and see you in the next video.